Hi everyone, today we're taking notes on section 3.2, which is on the product and quotient rules for derivatives. Okay, so these are really nice, and I'm going to write the product rule first. So product rule. And if you remember what a product is, it's when two things are multiplied together. So if you have a function, if h of x is equal to the product of two functions, f of x times g of x, then its derivative is f prime times g plus g prime times f. So for short, we can write that the derivative of h is f prime g plus g prime f. That is the product rule for finding a derivative. Again, you don't have to go through that whole long limit process. So find the derivative of each function. So let's say h is equal to, let's see, 2x times e to the x plus 5. So you'll notice that you have a product. It's 2x, and then we've got times e to the x. So this would be your f, this would be your g. And so the derivative of h would be, we're going to follow the formula, the derivative of f, so the derivative of 2x, which if you think about the power rule, what's the derivative of 2x? It's 1 times 2, x, and then you drop the degree by 1, so x to the 0 power. 2x to the 0 power is just 2. Or you can remember that the derivative of constant x is just the constant, okay? So that would be f prime. Then you have to do times g, so you just literally copy e to the x plus 5. Then the formula says plus. Then you do the derivative of g prime. So if this is g, you have to do the derivative of e to the x plus 5. The derivative of e to the x is e to the x plus the derivative of a constant is 0, so plus 0. So that would be g prime times f, which means just copy times 2x. Okay, so as my final answer, I would distribute this. 2 e to the x plus 10 plus, and then I like to write e to the x at the end, so 2x e to the x. This is a perfect answer right here. Okay, let's do another one. So if h of x is equal to, it doesn't have to be h of x, it could be m of x, n of x, f of x, it doesn't matter, call it y equals. It's just derivative of first times second plus derivative of second times first. Okay, so let's see. What if I've got 2x squared minus 8x times 6x squared? Okay, that's a product. You know, you have options here. You don't have to leave it as a product. You could totally distribute the 6x squared. But since we're in the product rules section, I'm going to leave it this way, and we're going to practice. So this would be f, and this would be g. First function, second function. So product rule says derivative of first. The derivative of 2x squared is 4x minus the derivative of 8x is just 8. So this would be f prime. It says times g, so you got to do times g. And so g is just 6x squared plus the derivative of g, so right here we need g prime. And so the derivative of g would be 2 times 6, 12, x to the first, times, formula says f, right? So f is just 2x squared minus 8x. And then you want to distribute, so I'm going to go like this. The answer would be, what is that, 24x to the third minus 48x squared plus 24x cubed. This will be minus 12 times 8 is 96x squared. Oh, I have some like terms, so I should combine those. So 24 and 24 is 48x cubed And then I've got negative 48 minus 96. I believe that is minus 144x squared. So this would be h prime right here, the derivative. Can you imagine doing that with a limit? It would take forever. Okay, let's do maybe two more. What if I have y equals e to the x times x plus x cube root of x. Okay, that 3 should really be here. I meant cube root, not x cubed. So it is, so the product is right here. It's e to the x times this parentheses. So this would be like our f, and this is our g. Before I begin f prime g plus g prime f, before I do this, I am going to rewrite this as one single term with a fractional exponent. So e to the x parentheses x plus x to the first times x to the 1/3 becomes x to the 4/3. Okay, now I'm ready. So this is f, and this whole thing is g. All right, so the derivative of the function is going to be f prime times g plus g prime times f. So here we go. F prime, the derivative of e to the x is e to the x, times g, I just copy, plus, now I have to do g prime. So what's the derivative of x? It is 1, plus the derivative of x to the 4/3. Remember, there's a little 1 out here. So 4/3 times 1, x to the, you're going to minus the degree by 1. I'm doing the power rule here. So I'll get x to the 1/3. And then times f, I just copy e to the x. Honestly, this is ugly enough to just leave this way. I'm going to leave it. We are good. We don't have to worry about distributing. You totally could, but what's the point? Okay, let me do one more product rule. What if I have, let's see, y equals 2x squared plus 3x times 2x squared minus 3x. You know, you really have to think, okay, let me write the product rule here again. It's f prime g plus g prime f. That's the product rule. This is f, this is g. I can totally do a product rule here. Or I can realize I have a pair of conjugates, okay, and FOIL them. So if I FOIL the conjugates, I get 4x to the 4th power minus 9x squared. And I can have a function that's just a polynomial. And so the product rule will not be required. So the derivative of y prime, with just 2 power rules. I don't need a product rule anymore. 4 times 4 is 16, x to the 3rd minus 2 times 9 is 18, x to the 1st. I'm done. Or if you wanted to do f prime g plus g prime f here, you would get the same answer. Okay, now for the quotient rule. Quotient rule. A quotient is something that looks like a fraction. There's division. So if you have h equals f over g, I'm doing the shorthand instead of writing h of x, f of x, g of x. I'm just doing h, f, and g. Then h prime equals f prime times g minus g prime times f all over g squared. That is the quotient rule for derivatives. Okay, so let's do a few examples. Quotient rule. Y equals, so we are finding the derivative. That's for all the problems I'm about to do. So if y prime equals e to the x over 5x squared. So that is clearly a quotient. It's something divided by something. So the top is f, the bottom is g, okay? So what would y prime be? Well, let's follow the formula. It says f prime, the derivative of e to the x is itself. It says times g, so you have to copy 5x squared, okay? Minus, make sure that's a minus, the product rule has a plus. Now it's g prime, so you have to do the derivative of 5x squared. What's the derivative of 5x squared? It's 2 times 5, and then drop the degree by 1, okay? Times, it says f, so just copy f, all over g squared. The whole function g squared. Okay, here's my final answer. I'm going to write e to the x always last. So 5x squared e to the x minus 10x e to the x all over, this is just 25 x to the fourth. Now, you should, within reason, simplify these if you can. You'll notice that 5, 10, and 25 all have a 5 in common. And there's an x here, an x here, and an x here. So I'm going to factor out a 5 and an x from the top, leaving me with x e to the x minus 2 e to the x over 25x to the fourth. And then that and that are reducible. So cross out 5, leaves a 5. X to the first over x to the fourth, cross out and make that a 3. So my final answer in the box, y prime equals x e to the x minus 2 e to the x over x to the third. Okay, and I say within reason. If it gets really, really ugly and complicated, we're just going to leave it at the very first step. But this was easy enough, okay? So, number 2, easy enough to factor out and reduce, that is. What if we've got h of x equals a rad x over x squared minus 3. So this is f and this is g, okay? Top and bottom, numerator and denominator. We're going to follow the quotient rule. So h prime, now before I do that, it is always beneficial to not have rads when you're doing a derivative, but fractional exponents. So I'm going to write that as x to the half instead of rad x. So 8x to the half. So f prime, the derivative of f would be 1/2 times 8, which is 4. X to that, remember you're going to minus 1. What's 1/2 minus 1? It's -1/2. Okay. Times g. G is x squared minus 3. Minus, now you have to do g prime. What's the derivative of x squared minus 3? The derivative of x squared is 2x. Minus the derivative of a constant is 0. Okay. Times f. So I just copy 8x to the half. All over g squared. If you have a binomial, you don't have to FOIL it out. I only did this because it was easy enough, but you don't have to FOIL this. You can leave it as x squared minus 3 squared. The only thing I don't want are negative exponents. So here's where it gets a little dicey. So instead of x to the -1/2, I have to write 4 over x to the half. There's a times x squared minus 3 minus, what's 2 times 8? That's 16. X to the first times x to the half is x to the 3/2 all over x squared minus 3 squared. And the annoying part is you can't leave a fraction within the big fraction. So here's what I like to do. I like to multiply this. You got to multiply the top and the bottom by the same thing. I just multiply by that denominator. Okay, you got to do it to the top and the bottom, and I distribute. So that and that are going to cancel, and I'll just get 4 parentheses x squared minus 3 minus, I've got 16x to the 3/2 times x to the half. So it's 16x to the 3/2 times x to the half. You're adding the exponents, is x to the 4/2, which is just x squared, over, and then we're going to write literally x squared minus 3 squared times x to the half. We're done. We're going to leave it just like that. Okay. Let me do one more quotient rule so we're all feeling okay. Okay, you guys can see that. Good. What's a good quotient rule problem? Oh, I know. This is a great quotient rule problem. What if y equals 1 over m to the 4th minus 3m squared minus 2? And you have to find y prime. That's a quotient. This is f, this is g. The quotient rule says f prime g minus g prime f over g squared. Let's keep that in mind. Okay, here we go. What is f prime? What's the derivative of 1? The derivative of a constant. That's 0. Times g. I'm just copying g. You know what that means. Minus g prime, the derivative of this whole polynomial. So let's see, 4m to the third minus 6m to the first minus the derivative of 2, which is 0, so minus nothing, times, so that was g prime. This is g prime right here. F is 1. All over g squared. M to the fourth minus 3m squared minus 2, quantity squared. We're going to leave that. We are not about to distribute that. So here's my final answer. 0 times anything is 0 minus 1 times anything. So I'm just going to go ahead and distribute the negative. Negative 4m cubed plus 6m all over m to the fourth minus 3m squared minus 2, quantity squared. It's a done deal. There it is. Okay, there's one more thing I was going to demonstrate, just one, and it's this. What if, this is, I promise this is the last problem, 5 plus x over x times e to the x. So what is this? Well, it's definitely a quotient because of the division bar. So this is f, and this is g. And if we want y prime, we are going to do f prime times g minus g prime times f over g squared. We're going to do the quotient rule. Here we go. I want you to see what happens. So the derivative of f, what's the derivative of 5 plus x? The derivative of 5 is 0 plus the derivative of 1x is 1. Okay? You can either do the power rule, 1 times 1, x to the 0 power, okay? Or you can remember that constant times x, the derivative of constant times x is just the constant. Okay, times g, so x e to the x minus, when you get to g prime, you're gonna notice that g is a product. So how do you do g prime? You have to use the product rule. Okay, so for just this portion, that one, we have to do the product rule here. So product rule says derivative of first, the derivative of x is 1, times the second, plus, the product rule says plus, the derivative of the second one, so the derivative of e to the x is e to the x, times, it says the second function. So derivative of first times second plus derivative of second times first, times f, times, so let's put parentheses around this, f is 5 plus x, all over g squared. Okay, we're going to clean this up a little bit. I've got x e to the x. Oh my, do we want to FOIL this? I really don't, so guess what? We shall not. 5 plus x, and then this is, you can either leave it this way, or if you square it, it's going to become x squared e to the 2x, okay? So, if there's ever a need, if there ever comes a problem, there will be a problem where we have to set this equal to 0 and solve, we would distribute this, we would factor it, but right now, we are happy right here. Okay, and that's the end of the notes. Thank you so much. Bye.